Hello friends, today we'll solve the communication system problems of GATE 2025 electronics and communication paper. Okay, so this is the first question. It is on FM. So consider a FM signal ft is equal to AC cos, and then is this 2 pi fct plus 3 pi 2 pi f1t plus 4 sin 6 pi f1t. Okay, where AC and FC are amplitude and frequency of carrier waveform, and F1 frequency F1 in hertz is, and F is in hertz, and FC is 100 times F1. Okay, so we need to find the peak frequency deviation of this FM signal. So we need for any angle modulated signal ft is equal to AC cos, then bracket 2 pi fct plus this phase part phi t. To find the peak frequency deviation, we typically use the formula 1 upon 2 pi d by dt of this part phi t. D by dt of it is because frequency is nothing but rate of change of phase. Okay, so maximum frequency is maximum rate of change of phase. Okay, so this here is the phi part. So delta f peak is 1 upon 2 pi times d by dt of this part, which we get as 1 upon 2 pi, and then this part is like 3 cos 2 pi f1t, 2 pi f1t plus 4 cos 6 pi f1t, 6 pi f1t. Then this we multiply, then it is 6 pi f1 cos 2 pi f1t, and then this we multiply, then this is 24 pi f1 cos 2 pi f1t, then we divide by 2 pi, so with 3 f1 cos 2 pi f1t plus dividing again gives 12 f1 cos 6 pi f1t. Now we need to find its maximum value. So both are cos, both are of same frequency, so simply the maximum value will be 3 f1 plus 12 f1, which is 15 f1. Okay, so option A is correct. This is the second question. It was on channel capacity of an AWGN channel. Okay, so it is saying that consider an AWGN channel with bandwidth W and noise power spectral density N0 by 2. Let P average denote the average power constraint in which of the following instrument dependence of the channel capacity C on the bandwidth W, keeping P average and N node fixed. Okay, so it's a standard question that standard fact that the channel capacity of AWGN channel first increases and then it becomes touch upper limit and become constant. Okay. So how do we get it? We see it. See, the channel capacity is bandwidth log to 1 upon S by N, where N is noise is signal to noise ratio, and is directly proportional to bandwidth, because more the bandwidth, more noise can come. So N is N node B. Okay, so where N node is noise power spectral density, so we can write as 1 upon S N node B. Okay, so there is a B here, which will which as B will increase, C will increase, but there is a B in denominator also. So we need to see how this thing works out. So for that you can see that since C is B log to 1 upon S N node B. Okay, so now what we do is we will use this simple formula of limit, that limit x tend to 0, 1 plus x raised to 1 by x is equal to E. So this is like 1 plus 0, so 1, and then 1 upon 0, so 1 upon 1 raised to power infinity indeterminate form. Okay, so we'll try to convert it in this form. For that what we'll do, we will like multiply here N node by S and S by N node. Okay, and then what we'll do is we will get this thing B N node S here, and we'll take S by N node as it is. So this is S by N node, and B N node S we can take to this power form due to log property. So this is 1 plus S N node B raised to power, okay, B N node S. So now if this part is X, then this part is 1 by X. Okay, now we need this 1 raised to power infinity form type thing. So for that what we'll do, we'll put limit B tends to infinity. Okay, so as B goes to infinity, this part will go to 0 and this part will go to infinity, so we'll get 1 upon infinity type thing. So when B tends to infinity, C is S by N naught, and then log 2, and then this part whole will simplify to E. So log 2 is 1.44, so we get 1.44 S by N naught. Now S is signal power, so it's a constant. N node is noise power spectral density, it is a constant. and log 2 is 1.44. So channel capacity of an AWGN channel, okay, after some time become constant, and upper bound on channel capacity is 1.44 times signal power to the power spectral density. Okay, so A is correct. Third question is on amplitude modulation, demodulation. Here it is saying that MT is band limited where W is in hertz. Consider two modulation scheme. First is DSP-SC. So here he has defined it as AC MT cos 2 pi SCT and AM signal as AC 1 plus mu MT cos 2 pi SCT. So here we have to see that envelope detector can be used for demodulation of DSP-SC scheme if MT is greater than 0 for all T. So this part is true because envelope detector can detect only positive peak. Okay, so envelope of this thing is ACMT. Okay, ACMT. Now if MT is greater than 0 and AC is always positive and MT is already positive, then their product will be positive. So mod MT will be equal to MT only, and envelope detector can therefore detect all the positive peak. Okay, so this part is true. And envelope of this amplitude modulation signal will be AC 1 plus mu MT. So here it is saying that can be used in AM scheme only if MT is greater than 0. So this part is false because here the condition is this part envelope should be greater than 0. So AC 1 plus mu MT should be greater than 0 and MT can be less than 0 also. Like for example, if you look at this BP Lethy book, then you can see that here the expression he has used is A plus MT cos omega CT. Okay, so here is simplified form where he has take mu equal to 1 and AC of carrier he has taken as 1 also. Okay, AC of this message signal he has taken 1. Then here you can see that if even if MT is less than 0, then also since A plus MT this envelope part is greater than 0, therefore its demodulation can be done successfully. But if A plus MT is less than 0, then it will create problem. So now the envelope will be this part, which is wrong. Okay, so in AM signal the envelope, or whether it is DSP-SC, the envelope part should be more than 0. So here A plus MT, or this part here which is AC 1 plus mu MT, should be greater than 0. So this part is wrong. So even if MT is less than 0 but this AC 1 plus MT is greater than 0, then also the demodulation of AM using envelope detector can work. Okay, so 1 is true, 2 is false. Fourth question is on this Hamming codes. So generator matrix of a 6-3 binary linear code is given. Okay, this is the minimum Hamming distance between code word we need to find out. So here you can see that this is the generator total generator matrix, and this part is the identity matrix 1 1 1, and this part is we call as parity matrix. Okay, so from this we make a table, and this part we write as identity matrix part, and this part we write as parity matrix part. So here we write as d1 d2 d3, here we write as p1 p2 p3. So d1 d2 d3 columns we just simply fill as usual, like 0 1 0 1 0 1 0 1, and then 0 0 1 1 0 0 1 1, then 4 0 4 1. And when it's come to p1 p2 p3, what we do is p1 is defined as d1 XOR d3. Why? Because this is p1, this is p2, this is p3. So d1 XOR d3. p2 part is d2 XOR d3. Okay, and p3 part is d1 XOR d2. So now we can see it that p1 p2 p3 is 0 0 0, because p1 is d1 XOR d3, so 0 XOR 0 is 0. Similarly all will be 0, and Hamming distance or Hamming weight is number of ones. So here there is no one, so it will be 0. Then in second case what we will do, it is like 0 0 1, so p1 will be d1 XOR d3, so this part which is 0 XOR 1, so 1. then d2 XOR d3 is p2, so this part is again 1, and then p3 is what, d1 XOR d2, 0 XOR 0 0. So like that we can fill this table easily. Okay, and now we just need to count the number of ones as Hamming distance. So here it is 3 ones, here it is 3 ones, here it is 1 2 3 4 ones. Like that we can simply make this table, and each of these 8 are code word. Okay, so now d minimum is nothing but the smallest possible Hamming weight of non-zero code word. Okay, so smallest possible Hamming weight is 3 only of a non-zero code word. So this part is 0, so this we ignore, except that, or we can say the minimum number of ones in a row except for all 0 rows is the minimum Hamming distance. So the minimum Hamming distance is 3. Okay, so easy. Fourth question is on information theory, and it is saying that random variable x take value -1 0 1 with probabilities px equal to -1 equal to x equal to 1 is equal to alpha, and x equal to 0 is 1 minus 2 alpha, where alpha is 1 by 2. Let g alpha denote the entropy of x parameterized by alpha, then which of the following is true. So in this question we have 0.3, 0.25 and 0.4. we need to find different entropy values at different values of alpha, but we used to keep in mind that entropy is maximum, all the three symbols are equiprobable. Okay, so although you can write the formula, entropy gx is like minus alpha log 2 alpha minus 1 minus 2 alpha log 2 1 minus alpha, which is like this, but you can clearly see that entropy of the random variable x take maximum value when all the three symbols are equiprobable, and this will happen here when alpha is 1 by 3. Why? Because when alpha is 1 by 3, then px equal to 1, x equal to minus 1 is 1 by 3, and px equal to 0 will be 1 minus 2 times 1 by 3, so 1 minus 2 by 3 is also 1 by 3, so all three will be, probability of occurrence will be 1 by 3 only. So therefore at alpha is equal to 1 by 3, all the three symbols are equiprobable, and therefore entropy at g at alpha equal to 0.3 is max. Therefore this part is correct, because g 0.3 will be greater than all other, so these two are correct. And here it is saying that g at alpha equal to 0.3 is lesser, and at 0.25 and 0.4, so both are wrong. Okay, so only b and c are correct. Okay. Fifth question is on mutual information from x and y Bernoulli random variable takes the value 0 1. The joint probability of mass function of the random variable is given here, and we need to find the mutual information. Okay, so how do we do it? So for that we first make the table. Okay, so here x equal to 0, x equal to 1, y equal to 0, y is equal to 1, because x and y are Bernoulli random variable taking value 0 and 1, and then we fill this table as given, and from this part we take probability of x equal to 0 is 0.2, we add them. Probability of x is equal to 1 is, we both add them, so this is the overall probability of x equal to 1. Similarly, if we add this, we get y equal to 0, we add this, we get probability of y equal to 1. Okay, now we need to first check whether x and y are independent random variable or not. So here you can see that p x equal to 0 and y equal to 1, x equal to 0 and y is equal to 1 is basically 0.14, which is also equal to probability of x equal to 0 dot probability of y equal to 1. So probability of x equal to 0 is 0.2, and probability of y equal to 1 is 0.7, which is again equal to 0.4. Similarly, probability of x equal to 0 and y equal to 1, x equal to 0 and y equal to 0.06, which is again equal to probability of x equal to 0 times probability of y is 0. So in all four cases you can see that this condition is satisfying. So yes, x and y are indeed independent random variables, and so because probability of x at x equal to x and y equal to y is equal to probability of x equal to x times probability of y into y, and we know the fact that whenever two or more random variables are independent, then mutual information between them is 0. Thus ixy is equal to 0. Or what you can do is you can use this formula ixy, mutual information between two random variables is hx plus hy minus hxy, where to find hx, what we do, we take this part minus of 0.2 log to 0.2, okay, and then 0.8 log to 0.8. This will give us hx. To get hy we get minus of 0.3 log to 0.3 and 0.7 log to 0.7. So this will give hy, and then to get hxy we will get minus of 0.06 log 0.06 plus 0.14 log 0.14, 0.02 log 0.02, and then 0.56 log 0.56. So this will give you this, and when we will add them and then subtract this, then you will get almost 0 also. Okay, these are two ways of doing it. Another question is on this random process. It is saying that consider a real value random process ft which is n equal to 1 to n a n p t minus nt. Okay, so where t is greater than 0 and n is a positive integer. Here pt is equal to 1 for t equal to 0 to 0.5 t and 0 otherwise. So pt is basically pulse from 0 to t by 2, and then it is 0. And coefficient an as pairwise independent 0 minute variance random variable. So this part is random variable, okay, and this part is a pulse, so it's a deterministic signal. Now he's saying that so this part is a random process, and the mean of the process ft is independent of time t, and the autocorrelation function is independent of time t or not. So we need to find these two facts. So first of all, let's see how does it expand. So it will expand like ft is equal to a1 pt minus nt, okay, plus a2 p t minus 2t and so on a n p t minus nt. So this will be like a1 a2 a3, and then this will be pt minus 1t 2t 3t like that. Okay, now where all these values are random, so this can be like this also, a1 can be like small, a2 can be large, like that. And here in second, so all these are sample function from the ensemble of random process. Here a2 a1 can be small, a2 can be large, and like that. Okay, and there will be many such sample functions of this random process. Now when we talk about the mean, so e of ft will be 0. Why? Because if we take like suppose take this instant, then e of ft is equal to e of random variable an, okay, and that's random variable an mean, it's a 0 mean random variable, so this will be 0. Or if you take like this instant and find mean, then everywhere the value is 0, so here also mean is 0. Okay, so mean of the random process equal to mean of the random variable only, because pt minus nt is a deterministic signal, so expectation of a deterministic signal is 0. So first statement is true, that mean of a random process independent of time, and here it is equal to 0. For finding the autocorrelation function, what we'll do is we will take first this as t1, okay, so this is t1 plus tau. In case 1, here we will take this as t2, and this will take as t2 plus tau. Okay, so now if we find this way, then it is expectation of t1 ft1 plus tau. So here it will, so that will be like expectation of this part ft1 will be like some an value, mean value, some an value, and here it will be all zeros, so an dot 0, expectation of an dot 0 is basically 0 only. But in case 2, if we take t2 here, then you can see that e of ft2 dot ft2 plus 2 will be equal to an dot an. Why? Because here also it will take some value from an, and here also it will take some value from an. So expectation, this is expectation only, so expectation of an dot an is equal to 1. Why? Because expectation of an square is nothing but it is the expectation of an whole square plus variance of n. This you know from random variable, which is like mean square plus variance of n. Now it is a unit variance, 0 means, so 0 means, so this is 0 square, which is 0, this is unit variance, so 1, so here it is 1. So for different time instant we are getting different autocorrelation value, therefore autocorrelation is depending on time. Okay, so this part is false, this part is true. Okay, so these were the 7 questions of communication system. These were the all 7 questions of communication system. One question, this one I have, this one I am reading, this one I am not still studied. So all 7 are discussed. Thank you.